morning. This is our first day of actually jumping into the unit. So this is day 1 of Unit 1 in Pre-AP Chemistry, and we're going to go over a few of our notes. So what you should do is make sure you have your notes out. If you want to do a split screen where you've got the video playing on half the screen and your notes on the other half, or if you want to print the notes out and write down. So anything that you see me write down on this PowerPoint, that is what you're going to need to make sure that you put in your notes, okay? And that's how this is going to work. One thing I did forget to mention in the introduction video is about our lab donations. I would like to take a lab donation for Pre-AP Chemistry because, as I said, we are going to do a lot of labs and we need to make sure that we are following all the safety procedures for those labs. And a big part of that is having gloves, having the right number of goggles and things like that. So a $10 lab donation would help us to purchase those materials, those things that we need to stay safe in the lab. So and I'm asking for a donation rather than just have you bring a box of gloves, because it's easier for me to purchase those gloves in bulk and to make sure that I get latex free, because that can be an issue for people as well. So it's just cheaper if I can get them. So lab donation would go towards gloves, paper towels, more safety goggles, and also towards purchasing a remote lab, virtual lab software that will help us to be able to do labs remotely. Either if you're in the remote learning method, you could do those labs instead of missing out on the in-person lab. Also, we could use them as practice before we actually get in there and start using a chemical. We can practice those techniques and what we have to do first. So lab donation of $10 would help us to get all of that material. So that would be greatly appreciated. So, and I forgot to mention that in the introduction. So, all right, so let's talk about Unit 1. All right, so the study of matter. Remember, and this part should be review, should be pretty easy for you to grasp this part. So the two main physical sciences are chemistry and physics. And chemistry is just the study of matter. So chemistry is the study of matter, whereas physics is the study of energy. Okay? All right. So remember, our definition of matter is anything that takes up space and has mass. Anything that takes up space and has mass. Again, that should be review. I'm sure you've learned that definition since elementary school. So there are 3 basic forms of matter, and those are ones we're going to spend a little time talking about. 3 basic forms of matter. We have solid, liquid, and gas. And what you need to remember about each of these forms: a solid has the least amount of energy. They are moving the slowest. So particles in a solid move very slowly. They, in general, are very rigid in their shape. It's really hard to draw a circle with this. So there's not a lot of space between them, and they're all lined up in a row, very tightly packed. And because of that, and their temperature, they are not moving very quickly. So the best example of that would be ice. The next thing is we have, whoops, there we go. Whoa, I'm making a mess with this. I'll learn how to use this mouse. All right, so the next one, we have liquid, and the example of liquid is water. So we have a little bit more space between our molecules, between our particles. So they are moving a little bit faster. And then the third state of matter is a gas. And in this state of matter, we have the greatest energy. So they are moving the fastest. Okay. and they have the greatest distance between the particles. They are completely, totally random. They take up as much space as they possibly can. The old definition you probably learned in elementary school is that gases have no definite volume and no definite shape. That means they fill up whatever container they're in. Liquids have a definite volume but not a definite shape. They take on the shape of their container. When solids have a definite volume and a definite shape. Okay? All right. So let's go back here. And let's do a little analogy for this. All right, so our soccer field analogy. States of matter can be compared to the game of soccer, for those of you who play soccer. Fans in the stands would represent a solid. They're really closely packed together in those seats. They're moving, but they're not able to move very much, okay? So then we move on to people that walk around the track, that are encircling the track or encircling the field. These would be like liquids. So spectators walking back and forth, concession stand and back, or walking around the track for exercise or whatever. Those would be our liquid analogy, because they're able to move, but they don't move as much or as fast. They're moving faster than the people sitting in the stands, but they're not moving that fast, okay? So they have more of a fluid-like movement, and they're able to spread apart a little bit more. And then the last one would be the soccer players. The actual soccer players on the field would be like gas particles. They have the greatest amount of movement. They are running up and down that field hundreds of times during a game. They're bouncing off of each other. They're going in what appears to be random directions, and they have the greatest distance between them. So those would be our gas particles. Okay, so just think about that as an analogy for the three states of matter. Okay, here's another diagram. This is what we call a particulate diagram. So make sure that you are able to draw that in your lab. We're going to be doing, or in your notes, we're going to be doing and drawing a lot of particulate diagrams. So make sure you're aware of, again, this is really hard to write with a mouse. I'm gonna have to really practice on this, or bring my touch screen. I think bringing my touch screen is going to be the best bet. Particulate diagrams. Ooh, that looks pitiful. Particulate diagrams are where we are drawing out the particles and their motion. And so we're going to be doing that a lot in chemistry and pre-AP chemistry, because it is something that you're expected to do in AP chemistry. There we go, maybe that's a little better. So this would be our solid, and you can see here that these particles are tightly packed together. There's not a whole lot of movement, not a lot of space to move around. These are a little more random. There may be a little more space, and so they can move a little bit freer. And then gas over here, they're filling up the entire container. They're as far apart as they can possibly get and still be inside that container. Okay. All right, so the next thing that we are going to discuss, I'm going to talk just very briefly about some lab equipment. We've probably already talked about these when we talked about lab safety in the first few days of class. So, all right, so some of this equipment. A beaker is mainly just used for storage. These lines that you see on the beaker are not exact measurements. Okay, so when you see That is not an exact measurement. It is just a good estimate. So that's what you need to remember, that beakers just estimate volume. They are not an actual accurate measurement. An Erlenmeyer is kind of the same thing. And the difference is just the shape. We like to use an Erlenmeyer when we have to swirl or mix things. Again, it's just used to estimate volume. It is not used to measure volume. Graduated cylinder is what we use to measure volume because it has all of these small graduations on it that give an accurate measure of volume. So when you have to measure the volume of a liquid, 100 milliliters of liquid or whatever, you're going to use a graduated cylinder, not a beaker, not an Erlenmeyer. Okay. Moving on. Okay, the next thing you're going to see is an evaporating dish. An evaporating dish is what we use to store or hold solids, especially when we need to heat them. Okay, a lot of times you'll have a solution that's a mixture of a liquid and a solid. We need to heat it up to boil off the liquid and leave the solid behind, and we do that in an evaporating dish because it's porcelain and it's able to withstand the heat a little better than, say, a beaker or something like that. Bunsen burner, this is what we use to heat things, and I'll show you when we get in the lab, we'll show you how to adjust this flame to get the best flame for your Bunsen burner. This is a wash bottle. We just wash down chemicals, rinse things off with those. Okay, just some very quick lab safety things. We are going to watch it. We should have already watched a video on it and taken a quiz, so this should all just be a little bit of review. We are always wearing our goggles and aprons. We do not walk in the lab without goggles, gloves, and aprons all the time. You need to wear shoes that cover your entire foot. So no sandals, no flip-flops in the lab. We always wear shoes that cover your toes. You're always going to waft things rather than inhale them. So waft means, I'll use an example. My coffee cup, waft means I'm going to move the air towards my nose. I'm not going to stick my nose there and inhale. That's not wafting, that's inhaling. And we don't want to do that because if there are dangerous fumes, they are all up in my nose and down my esophagus by now. So we always waft. You never want to point a test tube at yourself or another person, especially if we're heating it. You're always going to heat it so that it is away from yourself and away from people. So if this is my test tube, it's not going to point here, and it's not going to point to the person across from me. It's going to point where there's not any people. Always hair's got to be pulled back. Okay, so even as short as mine is, we're going to pull it back when we're in the lab because when you lean over, it can very easily get into a Bunsen burner or get into a solution, and that could be bad. This should go without saying, but this is one of the most important ones that I hope we remember. Oh, the last two are actually the most important ones, I guess. First and the last two. We never eat or drink in the lab, and we always wash our hands after lab. Okay, so whenever we're done with the lab, you are always going to go to the bathroom and we're going to wash our hands with soap and water, or we should have soap and water in the lab. We're going to wash our hands with soap and water before you go to your next class. Never eat or drink anything. Don't bring your water bottles, nothing. And you're always going to wear goggles, gloves, and aprons as well. Okay, so let's take a look at this picture and see what are they doing wrong and what are they doing right. So if we look at this one, we got this girl right here. She has her hair down. She has no goggles on, and that is not a safe place, safe way to do lab for her. This girl over here, she has her goggles, yes. But she's pointing the test tube. I keep making this bigger. She's pointing the test tube at herself, which is not good. And then this guy over here is eating a sandwich. That is unacceptable. This guy over here is hitting his test tube, but it's pointing right here at the guy eating the sandwich. So that's not a good situation. This girl looks like she's wafting like she's supposed to, but again, we have no goggles on. The same over here, no goggles, no goggles. Looks like he's playing around with stuff, and we do not have any horseplay going on in the lab. We are all down to business. We're in the lab, and it's not a place to play around or whatever. This guy is doing the right thing in that he is washing his hands, but his goggles are off. So we have some good things and some bad things going on. So make sure we are always following all of our safety procedures. Try and reset. There we go. Okay. All right, so the next thing we're going to talk about is the scientific method. And the scientific method is just a methodical way of solving a problem. That's all it is. So the first thing is we observe that there is a problem. Okay, so we see, yes, we have a problem. Why is this happening? Why do we observe this going on or whatever? And in this day and time, with all that's going on, this is a pretty exciting time for science, because we have a major problem, and we're trying to apply the scientific method to figure out a solution to that problem right now. So we make some observations, we have the formation of questions. And then the next step is we develop a hypothesis. Hypothesis is, it addresses the question that we came up with. It's what we think might be the answer to that question. It doesn't necessarily have to be the answer, but it kind of gets us going in a particular direction. It gives us a starting point, I guess. And then through the next step, experimentation and collection of data, we determine if our hypothesis, I'm not going to say was true or not true, but whether our hypothesis held up under that experimentation, or do we need to change our hypothesis? Okay, so experimentation and collection of data. Analysis of that data to form a conclusion is the next step. And then we repeat the whole thing all over again to make sure that our conclusion we came to was a correct conclusion. So hypothesis is a testable statement. So it's something that we can test, that can be measured, and it's often in the form of an if-then statement. So if this is true, then this will happen. That's usually the way we come up with hypothesis. Now, not always. They can be stated in other ways, but it does have to be measurable. Okay? You have to be able to test it. Oops. Okay, so when we do test our hypothesis, this is the experimentation part, we gather data. And most of the time we will put that data in a chart form. Okay, so your data is going to be what you measure or what you observe. That's the only thing you write down. And your data table needs to be clearly labeled. So these are bears, dolphins, and whales in these particular years, and it only includes what we're able to measure or observe. Okay, that's data. What we're able to measure or observe. All right, the analysis of the data. So the data is just numbers. That's all it is. It's numbers. It's things we measured, things we observed, and we did in the lab. The analysis is different. The analysis is when we interpret that data. So we use the data and we interpret that data. We do some form of calculation on it. We do some form of manipulation to it, usually in the form of a graph. Okay, so this kind of explains what those numbers are telling us. That's what the analysis part does. So the data part is just numbers, what we observe. The analysis is taking those numbers, doing a calculation on them, making a graph, and using and interpreting those numbers. What do they mean? Okay, so some things to remember about graphing data. Okay, so first off, we need to make sure we understand the difference between an independent variable and a dependent variable. Okay, independent variable are things that change or are changed on purpose. It's what we do to the experiment. What are we changing in the experiment? That is independent variable. A dependent variable is the thing that changes as a result of what we did. The thing that changes as a result of what we did. So I'm going to change the color. Oops, I can't. Yeah, I can. So let's get a little better color for this. All right, so our hypothesis, how will increasing the ball height or the drop height of a ball in 2-meter increments affect the height of the bounce after it hits the ground? So we need to identify the dependent variable and the independent variable in that hypothesis. Okay, so the independent variable, whoops. Is what we are going to do. We are going to increase the drop height. We're going to take that ball up higher and higher and higher and drop it. Okay? That's our independent variable because that's what we are going to change. Okay? The dependent variable, on the other hand, is the thing that changes as a result of that. So as a result of taking that ball up higher and higher and higher, we're going to watch what happens to the height of the bounce. So the height of the bounce is our dependent variable. The drop height is our independent variable. Okay, so let's try this one. Write a hypothesis for each of the following questions, then identify the dependent and independent variable. So on your notes, if I were doing this, I would take my notes and I would copy that question into my notes somewhere on a back page, on a separate page, add a page, however you want to do it. But this is how we're going to practice identifying dependent and independent variables. So what effect does increasing the temperature have on the growth of radishes? So what would be our independent variable? Let's see, we will circle our independent variable in red, and we'll do our dependent variable in yellow. So out of this, the thing that we are going to control is the temperature. So increasing the temperature is our dependent variable. The thing that will change as a result of that is going to be our dependent variable, which will be the growth of the radishes. Okay? So, temperatures are increased, then that is our independent variable, and they did this the exact opposite of the way I told you to do it. So I'm going to change those colors back. And growth of radishes is our dependent variable. Can't see that blue on blue very well. Okay. Here's another example. What effect does studying with music have on student test scores? So what is our independent variable? What is our dependent variable? Pause it for a minute. See if you can do this one on your own. All right. So music is played during study times. That is what we can control. We can either play music or not play music. So that is our independent variable. Student test scores are going to be our dependent variable. They are going to be what changes as a result of playing music. So our hypothesis, to write out the hypothesis, which is what you're supposed to be doing, identifying independent variables and dependent variables, but also actually writing out the hypothesis. So our hypothesis would be, if music is played during study times, student test scores will increase. Okay? So the test scores are what's going to change as a result of playing music or not playing music. Ooh, going backwards. I think we have one more. Oh, no, maybe we don't. We don't. We are done. So on Wednesday, we'll be talking about the table and about physical and chemical changes. Okay. Have any questions? Bring them to class with you. Jot them down. Email them to me. And we'll get those questions answered. And I hope you have a great afternoon. See you next time.